Hello dear students, I hope you all are fine. You all are doing well in your studies and you all are enjoying and learning a lot through our videos. Students, so far in binomial theorem, we have studied about the introduction part which consisted of binomial theorem and its expansion. And we also studied about Pascal triangle. So students, now in this lecture, we are going to make some observations on the basis of the expansion of binomial theorem. And on the basis of these observations, we are going to solve some questions which are directly related to general term. But the question solving will be done in the subsequent lectures. Today, we will be more focused on the observations that are made in binomial expansion. So let's get started with today's lecture. So in our previous lecture, we had discussed till binomial theorem. We understood the proof of binomial theorem using PNC. And then we took an example. Alright, I hope everybody must have understood that problem. Now, let me take you further theoretically. For that, I will have to write the binomial expansion again. I hope everybody will now be able to write down the binomial expansion of a plus b raised to the power n. What is the first term? The first term is nc0, a raised to the power n and b raised to the power 0. What was the second term? The second term was nc1, a raised to the power n minus 1, b raised to the power 1. It's very simple. Then what I am keeping in a ki power mein I am having the difference of these two, n and 1 will give us n minus 1, and b ki power mein I am keeping just this number, that is 1. So now you can write down the third term, nc2, a raised to the power n minus 2, difference of n and 2, and then b raised to the power will be what? 2. This will be continued, and now we are going to write down the last term, that is ncn, a raised to the power is going to be n minus n, that is 0, and b raised to the power n. So this is the theorem of binomial, and binomial theorem says the expansion of a plus b raised to the power n is going to be in this way, where n is obviously natural number or positive integer, right? Now we have to study about the observations on the basis of this expansion. What can we observe? Because we have obtained a series of terms which are getting added, so we can make some observations a plus b raised to the power n. The very first observation is, let me make you observe with this example. When we had expanded 2x plus 3y raised to the power 5, how many terms did we get over there? 1, 2, 3, 4, 5 and 6. So total number of terms were 6, that is 1 extra than the index. Similarly over here, in a plus b whole raised to the power n, what is happening? That this is the first term, this is second term, this is third term. Alright, so in first term we have nc0 over here, in second term we have 1 over here, in third term we have 2 over here. So this must have been which term? N plus 1th term, because here we have written in lower subscript as n. Are you getting my point? So we can say that in this expansion the total number of terms in this expansion are, I hope everybody must have calculated in their head, it is n plus 1, that is 1 extra than the exponent over here, which means that if I am going to calculate a plus b whole raised to the power 6, then uske expansion में कितने terms होंगे? There will be 6 plus 1, that is 7 terms. Alright, so this is our first observation which tells us about the number of terms in that expansion. Second observation, power of A is decreasing and power of B is increasing. Alright, try to understand this point, this observation, that as we move forward from first term to second term, then from second term to third term, the power of A is getting reduced continuously by 1 unit. Earlier it was n, then it became n minus 1, then it became n minus 2, and it kept on decreasing till 0. In last term it became what? 0. So that is what I have written, that power of A is decreasing and power of B, you can observe here power of B is 0, then it happened 1, then it became 2, and so on. Ultimately it went on to become n. So power of B is continuously what? Increasing. Now it is not essential that you memorize that always A decreases, always the power of A decreases and power of B increases. There is nothing to memorize, we are just observing. If I had written B plus A raised to the power n ka expansion, if I had written the expansion of B plus A raised to the power n, then what would have happened? The power of B would have decreased and power of A would have increased. Here power means index or exponent. Alright, so we are observing that in this binomial, the first term of the binomial, its power is getting decreased, and for the second term its power is getting increased in subsequent terms. Alright, this was our, let's see, third observation. You can also observe that if I add up the powers of A and B in first term, so here we have n plus 0, n plus 0 will give us n. In second term, power of A is n minus 1 and power of B is 1. So n minus 1 plus 1, I am asking you to add the powers, to add the exponents of variables in each term. So n minus 1 plus 1 will give us what? N again. N minus 2 plus 2 will give us n again. Let me show you. N minus 1 plus 1. N minus 2 plus 2. N plus 0. In all such cases, even in the last case, 0 plus n, the resultant is coming to be n. Alright, so we can write it down as sum of indices or power of variables in each term is equal to what? Is equal to the index of binomial, that is n. Alright, I hope you people are also observing along with me and understanding very well. Let's see fourth observation. Now the observation number 4 is going to be a very important one, because here we are going to observe the general term of A plus B whole raised to the power n, or general term in the expansion of A plus B whole raised to the power n. See, T1, when I wrote T1 term number 1, here we had NC0. When I am writing term number 2, here we had NC1. When I am writing term number 3, here we had NC2. So upon observing, I can say if I write term number r plus 1, so definitely there is going to be a binomial coefficient which is NCR, right? Because when here it was 2, it reduced to 1, where here it was 1, it reduced to 0, where here it was 3, it reduced to, it got reduced to 2. So if here I am writing r plus 1, here I am supposed to write r. Alright, so TR plus 1 will definitely include an NCR. Apart from that, I will have some power in A and some power of B. Because in each term I can see A raised to the power something and B raised to the power something. And in third point we had covered that addition of those powers or indices is equal to n. So whatever will be written over here and here, its sum is going to be equal to what? N. Alright, so now let's observe what do we have to write in exponents or powers or indices. In the first term, I have written A raised to the power n and B raised to the power 0. So as I already told you, what we are writing in A ki power mein is the difference of these two. that is difference of n and 0. See, you can observe over here in second term a raised to the power is having n minus 1, which is difference of n and 1. In third term a raised to the power is having n minus 2, which is difference of what? N and 2. In last term a ki power is having 0, which is difference of n and n. So in r term, what will be the difference of n and r? The difference of n and r is going to be nothing but n minus r. Alright, and b की power is 0 in first term. In first term b की power कितनी है? 0. And in second term b की power is how much? 1. In third term b की power is how much? 2. So in r plus 1/8 term b की power r. Alright, let me write it down again. So tr plus 1 becomes equal to ncr a raised to the power of n minus r and b raised to the power r. This is called as general term of a binomial expansion. Now most of the questions are formed on general term. If you are clear with the general term, you will be able to crack questions that are completely based on general term. You must to write down the general term of any binomial. Well, for example, let's say I have 2x minus 6y raised to the power 7. Okay? Or let's say plus. So here in place of a I have written 2x. If we compare it with the standard binomial, we can deduce that a is replaced with 2x, and in place of b we have written 6y, and in place of n we have written 7. That is why it is a binomial, a plus b whole raised to the power n. Alright, so we have compared it with the binomial. If I have to write down the general term, so general term is always indicated or denoted by tr plus 1, where general term is ncr a raised to the power n minus r and b raised to the power r. So I am just plugging in the values over here. This becomes 7cr because r is the variable. R will be r only. It is variable. It is not a constant. Alright, so this is 7cr. A means 2x raised to the power n minus r, which is 7 minus r, and b की जगह पे आ जाएगा 6y raised to the power r. So this is the general term of this binomial. tr plus 1 will be equal to 7cr, 2x raised to the power 7 minus r, and 6y raised to the power r. Now we can write it down in a much more simplified, or for you people it is going to be a complicated way. Whichever do you want to say, you can say. I can write down 2x raised to the power 7 minus r as 2 raised to the power 7 minus r, and x raised to the power is also 7 minus r. Power gets distributed over 2 and x. 6y raised to the power r can be written as 6 raised to the power r into y raised to the power r. So in all I am getting constants 7cr, 2 की power में 7 minus r, 6 की power में r, and with variable I have x raised to the power 7 minus r, y raised to the power r. Alright. So this much portion consists of constants because 7cr means selection of r objects out of 7. So it is going to be some numerical value, and 2 raised to the power 7 minus r is also going to be some numerical value, and 6 raised to the power r is also going to be some numerical value. So this is called coefficient. This is called coefficient of tr plus 1, whichever term it is. Alright. This part, only this part which consists of NCR, this will be called as binomial coefficient. This will be called as binomial coefficient. Alright, in this constant, the NCR part will be called as binomial coefficient. Please understand these terminologies, because in question if it asks you about coefficient and binomial coefficient, then you must be able to differentiate between what is coefficient and what is binomial coefficient. NCR stands for binomial coefficient, and along with NCR, if there are some other constants, then all those all together will be termed as coefficient, right? And this combination, entire combination, will be called as term. So please note carefully whether you have been asked about the term, whether you have been asked about the coefficient, whether you have been asked about binomial coefficient, because these are different things. So we were talking about the general term. So this is the general term. Now what is the advantage of general term? What is the advantage of studying or memorizing the general term? The advantage is we can obtain the entire series with the help of general term. How come? If I put r equals to 0 over here, let me show you. Yeah, for this, the general term is this one. TR plus 1 is NCR, a raised to the power n minus n, b raised to the power r. I was talking about the advantage. So if you put r equals to 0 over here, this becomes 1. So we get T1, that is first term. So if you are putting r is equal to 0 in LHS, you will also have to put it in RHS. So RHS become NC0, a raised to the power n minus 0 and b raised to the power 0, which is definitely the first term of this binomial written over here. Alright, when we are putting each and every value of r, we are getting each and every term of that binomial. Please focus over here. When I am putting each and every value of r, substituting r equals to 0, 1, 2 and so on up till n, I am going to get terms from T1 till Tn plus 1. And if I add them up, if I add all these terms, so what I am going to get? If I add all these terms, what I am going to get is the entire binomial expansion. Alright, so this general term also has great essence in showing the entire expression. Let me show you that a plus b whole raised to the power n can be written as summation, that is sigma, over NCR, a raised to the power n minus r and b raised to the power r, where r is varying from 0 to n. Alright, so you should understand that in concise way, in short form, we can write the entire binomial expansion, or we can express the entire binomial theorem by this particular box, which says a plus b whole raised to the power n. This is sigma. This symbol stands for sigma and it means summation. Summation means you have to put all the values of r, that is the variable, one by one. First you will put r equals to 0, then r is equal to 1 up till r is equal to n. This is the lower limit of variable and this is upper limit of variable. And if you keep substituting all the values of r and add them up, and for adding we are using this operator called sigma, whose purpose is to add all the terms that is contained in it. Alright, so if you add each and every term, that is T1, T2, T3, if you add each and every term, what you are going to get? You are going to get this series, that is binomial expansion of a plus b whole raised to the power n. So a plus b whole raised to the power n can also be written in this format. So students are supposed to memorize the general term and this particular summation. Alright, I hope everybody is understanding. So far we have made 4 observations. Total number of terms n plus 1, power of a decreasing, power of b increasing. Sum of indices of a and b of variables is n. General term, which is very important. In general term, we understood how to write general term. We understood what is the meaning of coefficient, what is the meaning of binomial coefficient, and what is the meaning of entire term. Alright, we saw this example, and now let me write down one more observation. NCR, it is not an observation, in fact it is an important point, that NCR will be called as binomial coefficient. NCR along with some constants, this will be called as coefficient, and NCR along with some constant and x raised to the power n minus r, y raised to the power r, this will be called as term. Which term? General term. Alright, next is rth term, or if it confuses you then you can consider pth term from end is equivalent to n minus p plus 2th term from beginning. Alright, what I am trying to say, that if in any questions you people have been asked that determine the pth term in the expansion of a binomial, here we have written this general term on the basis of the observations from beginning. Now if we have been asked the pth term from end, not from beginning, then you will have to write n minus p plus 2th term from the beginning. Alright, suppose it has been asked what is the 6th term from end, and x plus y raised to the power 13. So p becomes equal to 6. So 6th term from end will be equal to n is equal to 13. So n minus p plus 2th term from beginning. This is an example from beginning, and upon calculation this will give us 13 minus 6, 7 plus 2, 9th term, and for determining 9th term r will be kept as 8, and you can get tr plus 1 as t9. Alright, so sometimes if they ask you any particular term from the end, then you can calculate it from the beginning. You don't have to change the general term, just you have to calculate this n minus p plus 2th term. Alright, 7th, binomial coefficients that are equidistant from beginning and end are equal. Alright, what I am trying to say is NC0 is the binomial coefficient of first term, NCn is the binomial coefficient of last term. So number of ways to select 0 object is as good as number of ways to select n objects out of n. So these two are going to be what? Equal. So we can say that NC0 is equal to NCn. Similarly, NC1 is equal to NCn minus 1. This is the binomial coefficient of second term. This is the binomial coefficient of second last term, equidistant from beginning and end. So these coefficients are going to be what? Equal. So in general, NCR is equal to what? NCn minus r. Well, PNC also says this, that if you have to select r out of n objects, then it is as good as the number of ways of rejecting n minus r out of n objects. That is why we say that 5C2 is equal to 5C3, because selecting 2 balls out of 5 is as good as rejecting 3 balls out of 5. The number of ways are going to be equal in both the cases in terms of selection, right? So NCR is equal to NCn minus r. Wrapping up this, we are done with the observations. Please revise till here, and we will be continuing with some questions in next class.